these are some application problems of quadratics. Here we have a bridge, okay, supported by a parabolic arch. So in fact, quite a lot of building applications do use these kind of quadratic relations for arch shapes. First of all, they look nice, but they also are they are very functional as well. So bridge is supported by parabolic arch, which is 40 meters wide at the base. So I've drawn it here as 40, and the max height is 16. So from that base to the vertex is 16. It says write the equation of the arch. Okay, you can put this there's kind of two options here. We can put the vertex at the center. Okay, and if we do that, we make the equation look like this: y equals ax squared. Okay, there's no horizontal or vertical shift. Alternatively, okay, that's how it's been set up here. Okay, so that coordinate is going to be 0, 0. Okay, so alternatively, it could be set up in this way. Okay, I'm just going to do it in parallel over here. We could set this up so that the base, this represents the origin. Okay, so then we end up with ax squared plus 16. So we just show that the parabola has its vertex 16 up from the axes. Okay, so there's two ways to do this. Either way is fine. I think I prefer just not worrying about that plus 16 and doing this as an ax squared problem. Okay, so if I set this up as an ax squared problem, I need to find a. So I need a point on the curve. Okay, 0, 0 doesn't work because although 0 equals 0, that doesn't help me solve for a. I need another point on the curve, and that point would be this one here. I go over 20 down negative 16. Okay, since that's my origin, I'm going to go down negative 16. So if I plug that in, negative 16 equals a 20 squared. I can solve for my a value as negative 16 over 400. Okay, that simplifies to negative 1 over 25. So I now have solved the first part. I've got the equation of my parabola. That's all I needed. Especially, it seems kind of simple, but that's all I've set it up for is I need to just solve for a. My p and q values are 0 and 0. I don't need to solve for that. So there it is. There's my equation of my parabola. Now, let's say we set it up with our origin on the axes here. So this is going to be 0, 0 here. Okay. Now, if that's the case, my equation looks like that. And this coordinate, okay, so again, if this is 0, 0, this would be 20 to the right, definitely, but it's no longer 16 down. Okay, it's just going to be 0. That coordinate is going to be at 16, 0. So there's my equation based on my vertex being 16 plus 16. The coordinate for x and y that's going to solve for a is not going to be 20 negative 6. It's just going to be 20 to the right and 0 as my y coordinate. And I'm going to end up getting the same thing. I'm going to still, with negative 16 over here, divide by 400 equals my a. Yeah, a is still going to be negative 16 over 400, which works out like that. So both of these equations are actually perfectly fine. It really just depends on where you put the vertex. Okay, the vertex is at 0, 0 here. In the blue, the center would be here. The vertex would be at 0 and 16. Okay, so it's up to you. I'm just going to erase the blue here so that's not so confusing, so that the solution that I've solved for here with this picture is going to be the one in black. So the second part of this problem, though, asks us to find where is this arch 6 meters high. Well, it's somewhere around here. Okay, right about there is going to be about 6 meters high. So I just need to find the x coordinate when the y coordinate is, well, the height is 6. That's going to be 6, but that's not the y coordinate. The y coordinate is going to be this line here. That's our y. Okay. So I need to solve for y. Y in this case, if this is 6 high, the y positioning is going to be minus 10. I need, as long as I have established that y positioning correctly on my coordinate plane, I can't just plug in a height because y is actually not the height. Y is the distance from the vertex down to the curve. So once I've got that, now I can solve for this. So I get over 125 x squared. X squared works out to be 250, and then I get x equals plus minus square root 250. Okay, and that would represent this line right here. Let me just clear that up a bit. It's going to represent that line right there. Okay, and it's going to be the x position that gives me those points. Okay, so that at plus square root 250 here and at minus square root 250, which is over here, we would get the height of 6 meters. Okay, and again, if we wanted to do that here, the difference here would be, and maybe I should do it, here in the blue, since the x-axis is my base, my y height then would be 6. The y would actually represent the height in this case here, if I did it in blue. And then I would just solve this, but I would get the same thing. Okay, minus 16 from both sides. There's my equation. Negative 10 equals negative 125 x squared. Get 250 equals x squared. X equals plus minus square root 250. Okay, so same solution. It's just different relative positioning of the vertex.